Welcome aboard Station 204. My name is Jamie Higginbotham and I'll be your host for Space News this week. Let's go ahead and get started with our space traffic.
3, 2, we have ignition, and we have liftoff of the United Launch Alliance Atlas V rocket with AEHF-5 for the United States Air Force Space and Missile Systems Center.
Lifting off from Space Launch Complex 41 on August 8th at 10:13 Universal Time, we have an Atlas V rocket in the 551 configuration, which is one of its largest. Those numbers indicate a 5-meter diameter fairing, well, technically 5.4 meters to be exact, 5 strap-on solid rocket boosters, and 1 Centaur upper stage engine. The only rocket more capable in the Atlas V family is the 552, which has 2 Centaur engines, but it's not yet been flown. Well, technically there was also the designs for the Atlas V Heavy and the Atlas V Stage 2, but those will never fly, so back to the one that is flying. Aboard was the 5th Advanced Extremely High Frequency Program satellite known as AEHF-5. This is being flown for the United States Air Force. There are a total of 6 satellites in this constellation, which will be used for military communications. It's designed to replace the aging Milstar system. Here's a somewhat rare one in space traffic. We've got a ISS departure, but not an Earth arrival. Clocking in at 109 days attached to the space station, the Cygnus spacecraft said its final farewell on August 6th at 16:15 Universal Time. But its mission isn't over yet. Next up, the spacecraft will be sent to an orbit about 65 kilometers above the space station to deploy test CubeSats. Then, Northrop Grumman is planning several months of long-duration spaceflight experiments. Specifically, their ability to control the spacecraft with only gyros and not rocket fuel. Then, in December of this year, we can expect Cygnus to re-enter and break up in the atmosphere. And here's a quick look from our upcoming departures from Earth, Moon, and Mars. We may not have had many launches this last week, but it sure was a time for companies to test some stuff out. Let's start with an Orion propulsion static fire. On August 5th at NASA's White Sands Test Facility, the agency conducted a full 12-minute firing of the Orion spacecraft's ability to abort to orbit. This is one of the most complex firings that the system would need to perform. All 8 of the auxiliary engines lit up simultaneously, while at the same time the reaction control thrusters also periodically fired to simulate attitude control. Basically, it was designed to stress the prop tanks, valves, and as many subcomponents as it could in as close to a real-life abort scenario as possible. After the initial data review, NASA engineers deemed the test a smashing success. Next up, we're going to shift over to Launch Complex 39A in Cape Canaveral, where SpaceX performed some pad escape tests. And a huge shout out to Spaceflight Now for allowing us to use this incredible footage. If you look very carefully, you'll see some small square baskets moving away from the large fixed service structure on the right of the screen. This is what astronauts would get into should there be an anomaly with the Dragon systems that would require them to exit the pad very, very quickly. All in all, it takes about 20 seconds to get from over 80 meters high and move down to the ground over 360 meters away from the structure. And then they would move to a bunker or armored vehicle from there. These baskets were actually raised up 20 meters from the shuttle era where they sat at 60 meters high. The reason? The ingress point of Dragon is actually higher than the former ingress of the space shuttle. Keep in mind that the vehicle will not start to fuel up until they're already on the pad, so such an escape system really wouldn't be helpful if there was a problem with Falcon itself. This is helpful if there's a hypergolic issue on Dragon's propulsion system while it's still on the pad. Really, there aren't very many situations in which I can fathom that these would be needed, but it is nice to know that SpaceX is thinking of all these different scenarios. And finally, a bit of a bummer. The European Space Agency said that on August 5th, a high-altitude test of the ExoMars 2020 parachutes has failed. The test would demonstrate the deployment of a 35-meter parachute. The first 1.2-kilometer altitude test of the main parachute was conducted in 2018, and that was a success. But the next test in May of 2019, which had all 4 of the parachutes deploying in sequence at an altitude of 29 kilometers, that saw anomalies. And while the deployment mechanisms and sequences activated correctly, both main parachute canopies suffered some pretty decent damage. Based on that, engineers made changes to the parachute bags, and on August 5th, 2019, they tried again. But alas, it sounds like the engineers have a bit more work to do, and this is why we test and test and test some more. The good news is that they got data from the anomaly, and hopefully that's going to lead them to a solution. So, Vector Space Systems was in the news a lot this week. First up, on August 6th, Vector received a $3.4 million contract from the U.S. Air Force to lift experimental satellites known as Agile Small Launch Operational Normalizer. This payload would consist of multiple 3U CubeSats, which would all be delivered to low Earth orbit. Vector would have provided all the required dispensers, performed the payload integration, and of course, the launch itself. Notice I'm speaking in past tense even though they just won the contract, because something happened just 3 days later. First, Vector CEO Jim Cantrell was removed from the company and replaced with co-founder John Garvey. Then, in a statement, the company said that they needed to suspend their operations, or technically, quote, pause of operations, unquote, due to the change in financing. And then, later that day on social media, it started to trickle out that a lot of the Vector employees, likely most of the 150-strong workforce, had been laid off. So it's a bit of a bummer. We always like to see new space companies succeed and help push humanity forward. But the cold, harsh reality is not all of these small sat launchers are going to survive. New space is littered with the corpses of dead aerospace companies. And unfortunately, it looks like we're going to be adding Vector to that list of names. If you're interested in learning more about what Vector had been up to, we had Jim Cantrell on the show for Orbit 9.36, and we actually had him on again on Orbit 10.24, but that one was just talking in general the history of new space. Jim is a really fascinating individual, and while this is certainly a setback, I have little doubt he will land on his feet and hopefully rise from the ashes even stronger than before. And just a really quick update from Virgin Galactic. This week, the carrier aircraft White Knight 2, specifically VMS Eve, is being relocated to its new home at Spaceport America in New Mexico. The spaceship itself, known as Spaceship 2 or VSS Unity, will remain in Mojave while they work to outfit the passenger cabin for commercial flights. Spaceship 2 will join its carrier craft at Spaceport America later in 2019, where the final testing sequence will take place before passenger flights can begin. Right now, it sounds like Virgin Galactic is targeting 2020 for their initial paying customers. And if you want to see what the inside of Spaceport America looks like, Virgin Galactic is planning a special event this Thursday, August 15th. We're not sure if it's a press-only event or if we're going to get a live stream, but watch the Tomorrow Twitter account for more details as we get them. Now let's turn it over to the space weather woman, Dr. Tamitha Skov, for this week's report on our local star.
Space weather this week is definitely calming down. As we switch to our front side sun, you can see there's a remnant coronal hole that's going to be rotating in through the Earth strike zone, but it's really kind of hard to see, and we're not expecting all that much. We could get a little bit of a show at high latitudes over the next couple days, but probably not all that much. On top of that, the sun is pretty much spotless. There's a couple little bright spots here and there, but again, they're not really boosting the solar flux. So amateur radio operators and emergency responders, I'm sorry, the solar flux continues to be in the 60s, which means we do have poor radio propagation on Earth's day side. As we switch to the backside sun, well, the story isn't all that much different. There's still a spotless sun. We do have another coronal hole that's going to be rotating into Earth view here in the next couple days, and it could give us once again another little tiny storm, but probably not all that much to deal with because this is a solar minimum sun, and pretty much that's the story while our sun sleeps. Switching to our moon, we are now coming to the full moon phase, with a full moon being on the 15th. So you night sky watchers who are out looking for the Perseid meteor shower that is peaking right now, the best idea is to look to the east horizon just before dawn, while the moon is setting and before the sun has risen and it's still dark. And now for your Martian Minute. It's Sol 251 on the red planet, and winds are picking up out of the south-southeast at 18 meters a second. Dust storms are continuing along the southern polar hood and have spread a bit further north over Solus Planum, central Cimmeria, and the southeast region of Valles Marineris. Looking to the north, small dust storms have also been seen in northern Acidalia as they've moved southward across that region. Near the equator, skies have been mostly sunny except for some ice clouds forming in the afternoons. But thankfully, Curiosity rover in Gale Crater and the InSight lander on Elysium Planitia have enjoyed clear but brisk weather, with highs around -27 Celsius and overnight lows dipping below -100. For more details on this week's space weather, including when and where to see aurora, how GPS reception and emergency radio might fare, come check out my channel or see me at spaceweatherwoman.com.
Now, let's close this show out by taking a quick look at one of the first reusable rockets. Nope, it wasn't Blue Origin, and it wasn't built by SpaceX either. This was the DCX. Funded by the Strategic Defense Initiative Organization, construction of DCX, which stood for Delta Clipper Experimental, began in 1991. It was a 1/3 scale prototype, vertical takeoff, vertical landing, or VTVL rocket designed to test rapid flight and reusability. Now keep in mind, this is in the middle of the space shuttle era, where they were used to slowly refurbishable vehicles, certainly not rapidly reusable ones. Testing would start with the DCX prototype. VTVL hadn't really been done successfully before in atmosphere, and they needed to figure out how all of this would work together. They would fly a little, break a little, as a way to learn what was needed for the next steps. The original plan was, after the DCX test flights, they would move on to a larger vehicle known as the DCY, and once they had mastered everything needed there, they'd have a final production, single-stage-to-orbit unit called DC-1. And on August 18th, 1993, that's 26 years ago this week, the DCX took flight for the very first time. This flight lasted just under a minute, and then, after 2 more successful test flights, funding ran out for the program. This is when NASA and ARPA stepped in and helped provide additional funding. After the last test flight of DCX in 1993, NASA did opt to continue with what they called the DCXA program. This prototype had a bunch of upgrades, including a new aluminum lithium alloy oxygen tank, and the fuel tank was replaced with a carbon composite one. After some flight issues and fires with the XA, as well as a bunch of political motivation, NASA shelved the program in favor of their Venture Star, you might know that as the X-33. But that's another story. For those who work with VTVL vehicles today, the DCX was the pathfinder that helped other companies find their way. That is Space News for this week. Thank you so much for watching, and we have got a live show that should be really interesting coming up this Saturday at 1800 Universal Time. We'll be welcoming on Dr. Robert Hoyt. He's the CEO of Tethers Unlimited. We'll be talking about their Terminator tape, which will use the Earth's magnetic field to passively deorbit satellites, keeping low Earth orbit free for future outbound passenger vehicles, as well as what they call a refabricator. That's a 3D printer that can also self-recycle plastics, allowing for on-orbit manufacturing of plastic parts without any waste. They also have a water-based propulsion system and a robotic arm for CubeSat, so this is going to be a really fun interview. Make sure to subscribe to our YouTube channel and hit that bell icon so you get notices anytime we upload new Space News episodes or go live with our interview shows. I also want to thank all of the citizens of tomorrow for contributing to the show to make this happen week after week. We could not do this without you. The names you see on the screen directly financially support the show. If you would like to find out how you can get your name on the screen and financially support the show so we can keep making these episodes, head on over to youtube.com/TMRO/join. Thanks so much for joining us this week, and remember to keep looking forward to tomorrow. Hang on, I just want to say, this one was more complicated than usual because I started Invisalign, which has moved my teeth around, so literally saying the words feels different and is more complicated. So if I stumbled over words and didn't catch it, or if I inadvertently mumbled, I am sorry, but I've got like 17 trays I need to go through, which is the better part of a year, so it's going to be a while before I start talking like normal again.